My name is Michael Bryden II. This is Calculus 1000 Challenge 2016. The problem I will be doing today is Calculus 1000 problem number 73. Suppose that the range of G lies in the domain of F so that the composite F follows G is defined. If F and G are one-to-one, can anything be said about F follows G? In order to understand this problem, first we will look into one-to-one functions and how they work, and then we will go into an example to break it down. So what is a one-to-one function? A one-to-one function is a function when f of a is equal to f of b when a equals b, or no element of b has more than a single image of a. As you can see from the drawn function below, for every input x, there's an output y. So 1 goes to a, 2 goes to b, 3 goes to c, 4 goes to d. A one-to-one function also has to be able to pass the one horizontal line test. And this is demonstrated by the graph, where you can see that by drawing a horizontal line across each function, there are no 2 points that are marked by the line. Now, if this was a parabola, you would see that the line crosses completely over the u, which means that it is not a one-to-one function. So, the simple function that we will be using is f of x is equal to 3x minus 5. Now, you can see from the graph that this is a one-to-one function, and this will allow us to also talk about another property of one-to-one functions, and that all one-to-one functions have an inverse. And so you can see it passes the horizontal line test, no 2 points are matching, so every element of b has an image a. However, if you were to be given a function and not presented a graph, you would still have to determine whether or not it was one-to-one. And so this part entails finding the inverse of the function. Finding the inverse of a function is a fairly easy process. First, you want to take your function, f of x is equal to 3x minus 5, and essentially give the f of x value its true stated value, y, for the range. So now that you have y is equal to 3 of x minus 5, you want to switch the x into y, so that your function comes out to x equals 3y minus 5. Now you want to solve for y. So you add 5 to both sides. That gives you 3y is equal to x plus 5. And then to get y by itself, you divide by 3 on both sides. That leaves you with y equals x plus 5 over 3. Or f inverse of x is equal to x plus 5 over 3. Now we graph this, and we can see that on the graph, the green line representing our original function, and the black our inverse function, the x and y values of the function have switched, but the function still remains to be a one-to-one function. The horizontal line never crosses more than 1 point on the function once, so every element b has an image a. This now takes us back to what I was stating before, that with the inverse property of a function, only if a function is one-to-one does it have an inverse. And so, going back to the main question, asking about how g and f are related in regards to the function, g of x is essentially the inverse of f of x. So, when plugging it in, we'll take a value 2, for example, plug it into f of x. So we get f of x equals 3x minus 5, plug 2 in, you have 3 times 2 minus 5, 6 minus 5 equals 1. And so now, because this 1 is your y value, plug it into the inverse as the x, and this gives you x equals 1 plus 5 over 3, or excuse me, f inverse of x equals 5, x plus 5 over 3. So you plug in 1, and you have 1 plus 5 over 3 equals 6 over 3, which equals 2. And so this proves to you that not only is your function one-to-one, but it has an inverse, g of x, to the f of x.